this week's lesson. Now, this week we are gonna talk about Pythagorean theorem. Pythagorean theorem, right? Now, the Pythagorean theorem describes the relationship between the legs of a right triangle, the side that are adjacent to the right angle, and the hypotenuse, the side opposite the right angle. So has to be right triangle, and then we can talk about, then we can have Pythagorean theorem, okay? And then here is a theorem, in a right triangle, the square of the leg of the hypotenuse is the length of the legs equal to sum of squares, or c square equal a square plus b square. So I think many people Pythagorean theorem is a square plus b square equals c square. But many of you don't know why, right? So here I think I'm gonna explain to you in this lesson, this video tapes, we will explain why it is a square plus b square equals c square, all right? Now you can use the Pythagorean theorem to find the length of any side of a right triangle as long as you know the length of the other two sides. You can also use the Pythagorean theorem to determine if a triangle is a right triangle, okay? So that's the purpose we would have to learn the Pythagorean theorem, okay? Now, here is theorem, Pythagorean theorem, all right? So if a right angle has legs of the length a and b, and its hypotenuse has length c, then a square plus b square equals c square. And then c actually is a hypotenuse, okay? Yes. Now, here is how we calculate Pythagorean theorem. If a right triangle has legs with a length of 9 centimeter and then 12 centimeter, what is the length of hypotenuse? So you would take a Pythagorean theorem to calculate, to find it out. So c square equal a square plus b square. Now a actually is, we plug in 9, so 9 square. And then b square, which is 12 square. So therefore c square, which is equal 225. And then we take a square root for both. So square root of 225, and then c actually, we simplify this, and then we c actually is 15. So the length of hypotenuse is 15 centimeter, all right? So, and next, you want to take a look at this picture. This is a right triangle, okay? Right triangle, right here, right triangle. So we have a leg, we have a B, we have a leg, and then we have B leg, and we C is a hypotenuse. Now you can see this picture here, if we take A, if we make a square, so that would be A square. And we have to take a B, make a square, that would be B square, right? So according to the Pythagorean theorem, under the right triangle, all right, we A square plus B square, which is equal what? This area, right? So C square. So that means we take this area plus the second area is equal the third area, all right? So actually the Pythagorean theorem tells us this is the first area, this is the second area. We take a first area plus the second area, and we got which is equal the third area. Okay, that is the Pythagorean theorem. Now, if we take a look at another picture of next. Oh. Now here is a right triangle. This is a 3 unit, this is a 4 unit, this is a 5 unit, right? Now 3, 4, and 5. Now if we can make it as like a 3, and then this is a square like this, and then can we prove this is a Pythagorean theorem? Yes. Let's take a look next picture here. All right, so we have a 3, we have a 4, now 3 times 3, which is 9. And then 3 is linear for this, 4. And then how many square units are for this? This is 16. So 9 plus 16, actually, this has to be 25, right? And do we have 25? Yes, because we have 5, 1, 2, 3, 4, 5. Here, 1, 2, 3, 4, 5. 5 times 5, 25. So that would be 25, okay? So I think when kids they learn multiplication, all right? 3 square, actually they already know is 9. 4 square, which is equal for 16, right? And then if we add together, which is equal 5 square, which is equal 25, right? So I think the Pythagorean theorem we can teach as early as we can, like elementary school, like a 4th grader or maybe 5th grader, and then help them to understand the concept. And then basically this is the first area plus the second area to add together, which is equal third area, right? So that is the Pythagorean theorem. So in next time, when it comes to you, what's the Pythagorean theorem? You not just only know a squared plus b squared equals c squared. You know a squared, that means what? The first area. And then you will know b squared, what's the mean? That means the second area. You will know c, which is equal third area. All right, that's the Pythagorean theorem, okay? Now, what about converse of Pythagorean theorem? Let a triangle have a size of the lengths A, B, and C. If A squared plus B squared equals C squared, then the triangle is a right triangle. And the angle opposite the side of the length C is its right angle, okay? So here is a problem we can take a look. It's a triangle with a side length of 6 meter, 9 meter, and 12 meter a right triangle. So we know the side, we know the side, right? And then we want to find if this is a right triangle, if I have one is a 6 and the other 9, which is 12. So we want to know this triangle is a right triangle, yes or no. So we can use the Pythagorean theorem to find it out. And then you plug in, you plug in 12 as a C, and then A as a 6, B as a 9, all right? So you find 12 square, and then here's a 6 square, and here's a 9 square, and add together, see, they are not equal, all right? When they are not equal, what does this mean? That means this triangle is not a right triangle. This triangle is not a right triangle. So we can use the converse of the Pythagorean theorem to determine, to finding out this triangle is right triangle or not right triangle, okay? All right, now next, I'm gonna take you to take a look for the proof. The first proof is Chinese proof. The Chinese proof, they use the tangram, all right? The tangram to prove this, right? So you wanna take a look to square here. And then 2 square here, this square and this square, they have the same area, right? All right, so they have same area. So what else do they have the same? Do they have the same triangle? Yes, they have this, this is the same. And then here's blue triangle, and blue triangle is the same area. And then pink, and pink is the same. And then this one is the same. Yes. All right. So actually, you know, we have 1, 2, 3, 4. 4 triangle is the same, right? What else? Since this is 2 square, this square and this square is the same, and then they have therefore this one triangle is the same. So can we just prove this, you know, by visually? Did you get a aha moment for this? A times A, this is A squared, right? B times B, this B squared, is that right? And then C times C, actually this is C, is that right? So did you see this is A squared, B squared equals C squared? Yes or no? Yes or no? All right. I wanna take back to here, and then once you have a aha moment, we can fill in the algebra. Okay. So this is A squared. This is B squared. This is C squared. Right? Did you have a aha moment? Take a look. Take a minute to since this is a triangle and this triangle is the same. So not triangle. This is a square and this square is the same. This is square and this square is the same. All right. So we have A squared plus B squared equals C squared. All right. So you want to see the first area, the area of the first square. This is the first area of the square. And this is the second area of the square. All right. So first area of the area of first square is why this is 4 times 1/2 AB, because we have 1, 2, 3, 4, 4 triangles, right? And what about A square? This is A square. B square, this is a B square. What about they have the same same area of a 4 triangle. So 4 times 1/2 A1, 4 times 1/2 AB. So here C, this is a C square, right? So we can see the area of the first square, which is equal area of the second square. The area of first square is equal area of the second square, right? So that is 4 times 1/2 AB plus A squared plus B squared equal 4 times 1/2 AB plus C squared. So therefore, we can find it out A squared plus B squared equals C squared. So this is a Chinese proof, okay? All right, now take a look. Okay, now next proof is American proof. President James Garfield contributed a proof, and then he is 20th president of the United States, gave the following proof to the Pythagorean theorem. And then he discovered this proof 5 years before he became president. He hit upon this proof in 1876 during a mathematical discussion with some of the members of Congress. And it was later published in the New England Journal of Education. Let's take a look of President James Garfield's proof. And actually, I really like this proof, you know, because, you know, it can very easy to understand, right? So here is a trapezoid. Now here is a trapezoid, and then here's trapezoid. We have a combination of 3 different color triangles. So we have a yellow triangle, pink triangle, and then blue triangle, right? Now remember, the area of trapezoid is what? 1/2 base 1 plus base 2, and times the height, right? Now I'm gonna give you a minute to think, right? Take a look at this trapezoid. All right, so now here's 1/2 base 1 plus base 2 times height. Where is the base 1? Can we say base 1 is B right here? Can we say base 2 is this? All right. What about height? The heights, can we say A plus B is the height? So A plus B is the height, like this. If this is okay with you, then we can plug in this. When we plug in this, we have make it as A 1/2 A plus B times 1/2 base times B. Does that make sense to you? Now next, yellow triangle. Now yellow triangle is 1/2 base times the height. Pink triangle, 1/2 base times the height. Base is a C, height is a C, so that's why. Now next, 1/2 base is let's say B, height is A, right? So that's why we have this, right? That's why we have this. Okay. So now we work on to simplify this, work on the next step. Next step, you just take a plus b times a plus b. So therefore you got a squared plus 2ab plus b squared, right? And then next step, you can make it as a factor, take a 1/2 times this and times this times this, right? So that's why we have this step. All right, continue, repeat it for this. All right, and then therefore you can see, you can observe, this and this can combine. So that's why we have AB, right? 1/2 BA, 1/2 BA. So that's why we combine this, we make it this, okay? Now next, which one can cancel? This one can cancel, or AB can cancel, right? Because they are equal, so we can cancel for each other. So therefore, we got a 1/2 A squared plus 1/2 B squared equal 1/2 C squared, right? So therefore, we got it times 2 times 2 times 2. A squared plus B squared equals C squared, right? This is a American proof based on the trapezoid, okay? And next, I'm gonna go over a problem with you to finding out what's the AG is. All right. Again, we're gonna use the Pythagorean theorem to find it out. Now this time we have A is 2 squared, and then B is 1 squared, and then we have C squared, which is equal AC squared, right? So therefore, we have 4 plus 1 equal C squared, 5 equal C squared. So C actually is AC, so take a square root for both. AC is equal square root of 5. So this is square root of 5, okay? Next, we want to find AD. So we have A squared plus B squared equal C squared, right? So we have 5. We have 5 square root of 5, which is 5, plus 1 plus C squared. 6 is equal C squared. Take a square root for both. C is equal square root of 6. So this time C actually is AD right here, right? So square root of 6, right? So this, you can see, you can square root 2, actually square root of 4. 5, and 6, right? Did you observe the pattern there? Did you see the pattern there? Then we can say it is square root of 7, is that right? Since this is square root of 6, they can double check for this. Square root of 7, square root of 6, square root of 6, a square plus b square equal, right? C square, right? So 6 plus 1 equals c square. 7 equals c square. Take a square root for both. C equals square root of 7. Yes, this is square root of 7. Right? Square root of 5. Now, this must be square root of 8 if you find a pattern there. Right? Continue to this. So therefore, if this is square root of a, what is ag? Square root of a square plus b square equals c square. A plus 1, which is a c square. 9 equals c square. Take a square root for both. C is equal 3, right? So this would be square root of 9, which is equal to 3, right? Next, I want to take a look at for this problem. How we find x, 2x, okay, and 25, okay. Okay, we're going to use the Pythagorean theorem to find out this problem. So I'm here, a square plus b square equal 25 squared. So x squared plus 4x squared, right? Okay, can remember that it's just 4, it's not 2, okay? Many people got a mistake because make 2, because this is 2x, actually it's 2x, actually it's 2x times 2x. That's why we got a 4x squared, okay? And then people make a mistake right here. Be careful. So we have a 5 combined the like terms. So we have 625, right? And then x squared, which is equal 1 divided by 5 for both, right? So now next we take a square root for both. X actually is square root of 125, right? And then actually is x is equal 5 root 5. Simplify this. Always simplify, okay? And next problem like this, all right? So we want to find x, we want to find what's the y is here, okay? Now, let's take a look for this, you know, x and y. First of all, can we find the x? Yes, we do. We can find the x. See, we can do the triangle like this. Can we say x right here? And then since this is 1, this is 1, this is 1, so this is 1, right? And this is 1, right? So 1 square plus 1 square equal x squared. So B2 equal x squared. Take a square root for both. S is equal square root of 2, right? So we find x is equal square root of 2. Now what about this triangle? Actually, you know, this is a right triangle. This is a right triangle, okay? So square root of 2, this is a x is equal square root of 2. And then I'm gonna write triangle like this. This is x, this is a y, and then since this is 1, this will be 1, okay, 1. All right, so this is square root of 2 for this. A squared plus b squared equals c squared again. All right, a square root of 2 plus y squared is equal 1. 2 plus y squared is equal 1. Oh, no. Here, you know, sorry, make a mistake here. Actually, not this. This is not y. This is not y. Okay. My bad. Okay. 1b with 1. Okay, let me see. 1 square, which is y square. Okay. All right, so now it'll be 2 plus 1 equal y square. Now here 3 is equal y square. Take a square root of both. Y equals square root of 3, right? So we have a square root of 3 for this, right? All right, okay. So this is the problem, you know. For this problem, first of all, I think you have to solve for the one triangle, okay? And then next, you're gonna solve for the other triangle. The other triangle, here's x, this is y. Here's y. All right, because this is 1, y, right? So since this is square root of 2, right? And we find another triangle, this square root of 2. So this is a square root of 3, right? All right, I hope you enjoy today's video. Have a nice day.